Question 11. So this is a KB question here. So the first thing we should do is come up with an equation. Whenever we're dealing with KB, let's get a brush here first. Okay. Whenever we're dealing with KB, any equation we deal with has to involve water. That's because we know that if it's KB, we're talking about production of OH minus. That OH minus has to come from somewhere. And in this case, it's going to come from the water. Now, the advice I had given you when writing out these equations was that whenever you're dealing with KB, you take off OH minus, and whatever's left, the X here, will get H plus. So it'll be X, H plus. So the H will go up by 1, and the charge goes up by 1 as well. First thing we do is initial molarity, and we've got 0.42, 0 and 0 on these because it's initial. At equilibrium, the concentration of X goes down by an amount Z, and these will go up by an amount Z, so it's going to be minus Z and Z and Z there. We've got pH of 12.9, but what we're interested in is the OH minus, and this presents a problem to us. So that pH there needs to be converted into OH minus. Now what we're going to use here is this equation. pH plus POH is equal to 14. So there, that'll allow us to convert into something where we have POH. So what we can say is that POH is going to equal 14 minus the pH, which is 14 minus 12.9, and that's 1.1. Now 14 is the counting number, so it doesn't count for significant figures, so 1.1 is what we get here. Now what we know is that the concentration of OH minus then can be gained by going 10 to the negative POH, 10 to the negative 1.1, which is going to be 0.079. And after that, we can go ahead and do our KB expression. So KB is equal to XH plus OH minus over X. We substitute in all our values. Z squared, 0.42 minus Z. And we've got 0.079 squared on top. And down the bottom, we'll have 0.34. So that's correct for significant figures because that would be 2 decimal places, and after we take away the 0.079, it becomes 0.34, which is 2 decimal places. The answer comes out to be 0.232, and that's what I'm requiring for this, so it makes my grading easier. But your test answer would have been 0.23, which would have had 2 significant figures.